Hey guys, alright, we're going to continue talking about solving systems of equations. We're going to look at other methods that you can do algebraically or with calculators to solve 2 by 2 and 3 by 3 systems. So one of them is Cramer's Rule. And Cramer's Rule comes from doing the elimination method. You kind of figured out, sometimes we try to make these meet at maybe 5 and negative 5 to cancel out for x, or positive 2 and negative 2 for y. So Cramer's Rule guarantees that we always get these equal and opposite. And so this is just a system of doing that. Okay, so it does kind of involve matrices a little bit, sort of. So to use Cramer's Rule for solving a 2 by 2 system, if we have a system of linear equations in this form, basically what we're going to do is we're going to take what's called the coefficient matrix. Oops, here we go. This is called the coefficient matrix of the left-hand side, and that means the numbers in front of x and y. And so if we wrote that out, it would just be the a and b, d, and e. So we kind of ignore the x's and y's in front of them, but we kind of have a column that involve our x's and a column for our y's. Okay, so this is called the coefficient matrix. Coefficient matrix. Okay, and the first thing we're going to calculate, there's something called the determinant that we use with Cramer's Rule. So this is called the determinant. Okay, and the first thing we're going to calculate, basically if we do this, this is like a little process. If we do this 3 times, we'll get our solutions for x and y. And it's a pretty easy process. So what we're going to do is we're going to take, when we find the determinant, we use these vertical bars rather than these brackets around our matrices. So just like a vertical bar, if I can draw one straight enough. If you see just vertical bars and they're not really brackets around a matrix like this, it means we're finding the determinant. So to find the determinant, we're going to do 2 things. We're going to multiply and subtract. Okay, and we start in the top left corner. So kind of like you're reading a book, top left corner. So we're going to start by taking our first diagonal, which is a and e, and we're going to multiply these together. So I'm going to get a times e. Okay, and then we're going to subtract the product of my other diagonal. So we're going to multiply d and b together and subtract it from the first one. Okay, and this is the determinant of my coefficient matrix, whatever this number turns out to be. Okay, and this will be some sort of number. So let's use our practice problem over here for now. So my coefficient matrix, my coefficients in front of x and y here would be 1 and 1. And for x and y in the second equation would be 5 and negative 2. Okay, there's my coefficient matrix. And if we find our determinant, 1, 5, 1, and negative 2. Gosh, that's pretty jammed together. Let's make that a little nicer. 1, 5, 1, negative 2. Okay, so we're going to find our determinant. Sometimes you'll abbreviate that DET. So we're going to start by multiplying my first diagonal. 1, remember start in the top left like a book. 1 times negative 2 is negative 2, minus, which is just part of the formula, 5 times 1, which is 5. So negative 2 minus 5 more is negative 7. That is the determinant of my coefficient matrix. Okay, so this value we're going to use, and I said if you can do this process 3 times, and it's a pretty quick process once you get the hang of it, you can do this 3 times, we'll get straight to our answers. Okay, so here's how. When I need to solve for x, we're going to take the coefficient matrix here, A, D, B, E. Okay, basically, well, this value, the determinant, goes in the bottom of my fraction. So I'm just going to write determinant, DET, down here. Jeez. DET, so determinant. So this number is going to go in the bottom of my fraction. So similarly for my example over here, -7 is going to go on the bottom of this fraction I'm going to set up. Okay. To find the number that goes in the top, we're going to do one more determinant. And if we're solving for x, remember we said there's kind of an x column and a y column. If I'm solving for x, we're going to replace the x column. Instead of having a and d, we're going to replace them with these values over here. So in place of my x column, instead of a and d, we're going to write c and f, those numbers. And then the y column stays the same, b and e. And we do our determinant with this. Okay, so starting in the top left, you would do c times e, which would be ce, minus b times f, or f times b. And that's over my determinant. And this fraction gives me my answer for x. So let's try that with our example. Okay, so we're going to need to do one more determinant. And since we're solving for x, we're going to replace the x column. Remember, this is like our x's and y's. We're going to replace the x column. Instead of having 1 and 5, we're going to put in these numbers at the right, 3 and 8. So the y column stays the same, 1 and -2. And we just calculate our determinant. So start in the top left like a book. 3 times -2 is -6, minus 8 times 1, which is 8. -6 and -8 make -14 over -7. And that tells me my x coordinate is +2. Okay, so we found x. That wasn't too bad. I know it seems completely different, and you'd probably just maybe want to go with elimination or something here, and you can get the same answer. We're just introducing you to a new method. Okay, so obviously we still need our y coordinate, and yeah, you could go back and use substitution, but that's not really what Kramers Rule is about. So to find y, that denominator again is still our determinant. So in my example, -7 would still be in the bottom. That's the determinant from the coefficient matrix. Always goes in the bottom of both fractions. And as you probably suspect, if we're solving for y, we're going to replace the y column with c and f. So we're going to replace the y column. So the x column from the original, in this case, was a and d, the x column in the original. So a and d would stay the same. But instead of having b and e here, we're replacing them with c and f. We're replacing them in the y column. And again, if I do my determinant multiplying by my diagonals, I have a times f minus d times c over the determinant of my coefficient matrix. Okay, so let's do that with the example. So this time, we're going to replace the y values with 3 and 8. So on the right-hand side, we're going to replace these with 3 and 8 and keep the original x values. So we're keeping 1 and 5 from the original. And we'll do our determinant. Those little stars, by the way, I'm just marking to remember to start in the top left. You don't have to write those. 1 times 8 is 8. Minus 5 times 3 is 15 over -7. And I end up with -7 over -7, which is +1. And there's my solution, 2 and 1. Okay, so that might have been confusing. Let's do another example. Hopefully this will clear it up. So we're going to do the same thing with Kramers Rule. Okay, so let's start off with our coefficient matrix. So my coefficient matrix would be, oops, I don't have it selected, there we go, 3 and 1, so 3 and 1, and then 1 and 2. Okay. And the first thing we do with that is we want to find that determinant. So we multiply by our diagonals. Remember, start in the top left. 3 times 2 is 6, minus 1 times 1 is 1. And so my determinant is 5. So when I go to set up and solve for x, I'm going to put 5 in the bottom. And when I go to set up and solve for y, we'll have 5 in the bottom. Okay. So we just need to set up and solve these other two determinants. When we're solving for x, we're going to replace the x column. Remember, this is like x and y. We're going to replace the x column. So instead of 3 and 1, we're putting in these numbers at the right. So instead of 3 and 1, we're putting in the 2 and 6, and we keep the y column the same. So solving for x, replace the x column. Solving for y, replace the y column. Okay, so let's finish solving for x. I'll do my diagonal here. 2 times 2 is 4, minus 6 times 1 is 5. So we have 4, oh, oops, sorry, 6 times 1 is not 5. 6 times 1 is 6. So we end up with 4 minus 6, which is negative 2/5. So we end up with negative 2/5 for x. When I'm solving for y, we keep the original x column, so 3 and 1 stay the same, but our y's are going to get replaced with 2 and 6. So I'm multiplying here. 3 times 6 is 18, minus 1 times 2 is 2, and we end up getting 16 over 5. And there's my y coordinate. So the solution to this system, which had some fractions, 2/5, negative 2/5, and positive 16/5, is our solution. That's my x, that's my y. And Cramers is nice to deal with fractions too, because you'll never see a fraction until the very end here, unless you happen to have fractions in front of x and y to start with. But it's a nice method where you really don't see the fractions till the very end, and you just got to reduce all the way. Okay, so Kramers Rule is pretty cool. It can be applied to 3x3 systems, but to be honest, there's much nicer ways, and you got to remember a lot of extra stuff to apply Kramers to bigger systems. So instead, when we're solving a 3x3 system, we're going to use reduced row echelon form. Before we get to that, let's go back for a second. Okay, so let's say I wanted to check this system with my calculator. So you can do this in the scratch pad. I just started a document and added a calculator page. Remember that we can go to menu in the calculator part under algebra, oops, menu, algebra, oh geez, it did it again, menu, algebra, there we go, solve system of linear equations. And so we have two equations, and I can type those in. 3x plus y equals 2, and x plus 2y equals 6. And we can use our calculator to check, and indeed we did get the correct solutions there. Negative 2/5 and 16/5. That's what we ended up with. Okay, so pretty nice way of checking those if you're doing a calculator part of a test for a 2x2 system. Remember we had that linear solver. The other way I'm going to show you is to solve with reduced row echelon form. And this also involves making everything a matrix. Okay, so to use this method, I do need all the numbers that we're equal to on the right. In our next example, we're going to have to kind of force them to be on the right. But that's the setup I need to use this nice quick method with the calculator. Okay, so we're going to do our rows here and columns and just the coefficients. That's all we need. So we've got negative 2 for x, negative 1 for y, positive 6 for z, and that's negative 1 at the very right. So I like to draw on this vertical bar. It's not really necessary. You won't see it when we input it in the calculator. But let's just remember this is what it's equal to. So my other coefficients are negative 2, negative 1, negative 2, and 15. And for my third row, we have negative 1, negative 2, positive 2, and 0. Okay. If you were missing any variables, like if there wasn't an x or y or z in one of these equations, you just put a 0 for that variable. But remember, this is kind of our x column, our y column, our z column, and what they're equal to. All right, so here's how we can use our calculator. We did this once, I think, with one of our word problems. I'll try to find a good spot here. All right, so we'll go to a new calculator page, and we're going to do menu, matrix and vector, reduced row echelon form, RREF. And in fact, all that does is type RREF parentheses. So if you really wanted to not have to go through the menu, you can type RREF parentheses. But now I need to go back to matrix and vector. I need to create a matrix. So create matrix. And rows go horizontal, columns go vertically. So I'm going to need 1, 2, 3 rows, but I'm going to need 1, 2, 3, 4 columns. So 3 rows, but 4 columns. So I have a nice setup where I can put in all those coefficients. So I found a fast way to put them in is if you use this tab key down here. If you hit tab, it takes you to the next square. So I'm going to use my keyboard because it's much faster for me. But if you're typing these in by hand, just use that tab key, gets you to the next box. And when you're done with the first line, it takes you to the second line. So -1, -2, 15. -1, -2, 2, and 0. Oops, 0. Okay. And if we type that in, if this solution or system does have a nice solution, we'll see in my x column I only have 1, 1. And if I'm reading this, it says 1x equals -6. So they basically just told me that x is -6. So x is -6. And go back to my calculator. Now it's telling me in my y's column 1y is equal to 1. And then in my z column 1z is equal to -2. And of course I could check this by plugging in. Sorry that got really sloppy, but I'd write my system -6, 1, -2. That's my x, y, and z solution. And my calculator just saved me a ton of time, as you guys remember, trying to solve these by hand. So that's a pretty cool method. Okay, let's do our last one, and you'll definitely see one like this on your test, so make sure you know how to do this one. Review this video if you need to. We want to write the equation of a parabola that passes through these 3 points in this form. Okay. So to get it in this form, we have 3 values we need to find. We need to find A, B, and C. Those are our 3 unknowns. Okay, so to find those 3 unknowns, they've given us 3 points, 3 x and y pairs that we're going to substitute in for x and y. Gosh, I don't know what happened up there. For x and y. Okay, so let's do that. Now I know this is going to be a little weird. I'm instead going to move the y to this side. And it's really for the same reason I talked about back in that last page, that I need to force these values to be on the right to use matrices. And I'm going to want to use a matrice to solve this so I don't have to spend a bunch of time solving it by hand. So I'm going to put the y on the right. It's a little weird, but we'll just go with it. Okay, so we're going to substitute in. Let's use our first point. So for x, I'm going to substitute in -1. -1 squared plus b times x, which is -1, plus c is equal to my y coordinate, which is 2. Okay, next, we'll simplify this equation. 1 squared, or -1 squared is +1, so I have 1a. -1 times b is -1b, plus 1c, I'm just putting the 1 in front of there, is equal to 2. Okay, so there's my equation we got by plugging in that point. So next we're going to do the same thing for our next point. We're substituting in +1 for x. So a times 1 squared plus b times 1 plus c equals my y coordinate, which in this case is 8. So we're using 1, 8. So 1 squared is 1. That gives me 1a. 1 times b is +1b. Plus our 1c is equal to 8. There's my second equation. And of course, we're going to do the same thing with our last one. Now I'm substituting in -2 for x. So b times -2 plus c. And we're going to substitute in +2 for y. Okay. So -2 squared is +4a. -2 times b is -2b. And 1c equals 2. Okay, and so here is my system of equations I want to solve for. And we need to find the values of a, b, and c to write our equation. So that's where we're going to use our calculator. So if I come back in here, we use our calculator. I don't think I have a blank page. that's fine. We'll use this new one. So again, I can go through the menu and do RREF, or you can type it in, RREF parentheses. Another place to come up with matrices other than menu matrices create is if you go to the math template key, so the one between 9 and the book down here, there's some matrices set up. If you click this one that looks like a little 3x3 matrice right here, and you select that guy, you can select any size matrix. So 3 rows, 4 columns, that gets me the setup I need. I'm going to move this over so we can, well, maybe I'll just move it down. There we go. And then we'll type them in. So I have 1 for A, -1 for B, 1 for C, and that equals 2. Then I've got 1A, 1B, 1C equals 8, and 4A, -2B, and 1C equals 2. And I can see that system does have exactly one solution, and that A, this is my A column, is equal to 1. So I get A is equal to 1. Looking back at my calculator, it tells me 1B is 3, and 1C is 4. So B equals 3, and C equals 4. So when I come back to my equation, y equals ax squared, x squared, plus bx plus c, I can now substitute in my values for a. So a is 1x squared, or x squared, plus 3 times x, that's my bx, and plus 4, my c value. And this is my equation of my parabola that will go through all 3 of those points. I can check that by graphing and going to the table and making sure all those points are in there. But that's it.